Now, student, welcome to this first lecture of metrology and quality control. As during our college time, in the regular classes, we have covered the metrology portion fully. Now, in the last lecture, I have covered the quality control content, the definition of the quality control, the quality audit, the regarding the explanation regarding the quality, why quality is necessary, what is inspection, all those things I have explained to you. Now we will discuss the specific limits and regarding the control charts which are used in the quality control methods. First of all, why the charts are necessary, what sort of techniques are used in the industry to control the rejection of the product. That is very important. There are so many techniques used in this scenario. Now, today I will just take one example and I will explain you what is the Six Sigma method used to control the rejection in the production. Now, what is Six Sigma? Now, what is Six Sigma? Six Sigma is nothing but a term generally used to indicate a process. Is it within the control or not? Now, what is process? Process is nothing but the production process or the manufacturing process from raw material to the finished product. Now, what this what this Six Sigma is? Six Sigma means there is a line which is called as a central line, and central line is nothing but the zero tolerance line, where it is called as a basic dimensions. Apart from these basic dimensions, there are two dimensions. We have learned this in the metrology, that there are two upper control limits and lower control limits. If the product falls within this upper control limit and lower control limit, then we say that it is accepted. But in an industry, how it is controlled? For that purpose, a Six Sigma limits are used. So Six Sigma limit is a quality assurance. Now, what purpose? What is Six Sigma? It is a continuous effort to achieve stable and predictable process results. Predictable process results means the results whether it is accepted or rejected by a it is very important for the business. Again, what is Six Sigma? It is a manufacturing and business process have a characteristics that can be defined, measured, analyzed, improved and controlled. It is a process of defining, measuring, analyzing, improving and control. Again, what is Six Sigma? It is achieving a sustainable quality improvement. We need a continuous quality improvement in the product. So it is a sustainable quality improvement, required commitment from the entire organization. Six Sigma is a process which involves entire organization, particularly from the top level management, because whenever bottom level management demands something, top level management try to cut off the cost incurred in the quality. But to gain the quality, we need a support from the top level management. So what are the features that set Six Sigma? A clear focus on achieving measurable and quantifiable financial returns from any Six Sigma project. One has to assure, an engineer has to assure that by implementing this Six Sigma, there will be a quantifiable financial returns we will get. And increase emphasis on strong and passionate management, leadership and support. A clear commitment to making decisions on the basis of verifiable data and statistical methods rather than assumptions and guesswork. During a process, we generate so many data. On the basis of that data, we are making the decisions not on the basis of assumptions or guesswork. So this process is mainly implemented in the industry. Now what is that this process? This process is nothing but there is a center line, as we have discussed in the earlier process, that there is a center line that is called mean line. The product must follow the mean line of the dimension. Suppose you are manufacturing a shaft of 50 mm diameter. So 50 mm plus minus 0.05 means 50 mm is nothing but the basic dimension, basic line, that is called the mean line. And plus minus 0.05 means on the lower side minus and the upper side it is plus. But as we have already discussed that no one can manufacture a similar component at the same time. So for that purpose we are giving the tolerance. We cannot manufacture exactly 50 mm diameter shaft for a longer time. There is a variation. So for the variation there are so many reasons. We have already seen those variations, those errors. Now therefore the product will fall either in this 6 negative side, lower side, or in the positive side 6 sigma, or 6 or the positive side 6 sigma. Suppose a industry is manufacturing a small ball. Take an example of ball bearings. Most of the balls will follow the center line. Most of the product will, because that is our aim. That is the aim of the product manufacturer, that the most of the product should fall at the middle line. So middle line you will find the maximum product. Some product have a slight variation on the positive side or a negative side. So there is a less, the products are less here. Some products will again go towards the negative positive side of that limit. Suppose 50.04, because our limit is 0.05 ends here, 0.00 negative 49.05 will ends here. So maximum product will be falling at the center. That's why it is having a typical shape. This shape is called as a bell shape, or in technical term it is called as a normal distribution curve, because it is a normal distribution. Every manufacturer will try to manufacture the product in which are matching towards the mean line. Here the products are matching at the mean line or maximum. Suppose if I plot the graph will be like this. This is the mean line, this is the 6 sigma of the maximum, this is negative minus 6 sigma means upper specification limit, this is lower specification limit and limits, and this is the mean line. But it has been found that for over a long period of time it has been found that the products will fall within 3 sigma in this side on positive side and 3 sigma on negative side. Means maximum 99.7% products will be accepted if they fall within the limits. Now out of these limits will be definitely rejected, because these are not as per the specification. So these will be rejected. So this is 6 sigma minus and this is 6 sigma plus, but the limits are 1, 2, 3 plus 3 sigma and 1, 2, 3 minus 3 sigma. So this is called the normal distribution curve. Now, as I explained just now that these are the limits. So from this mean line, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. This is the mean line. So if you take the first standard deviation where we called as plus 1 sigma and minus 1 sigma. So first standard deviation is plus 1 sigma and minus 1 sigma. In this deviation you will find that the 68% of the product will fall within this line, because no manufacturer will wants to reject the product. So 68% will fall within this product. Then the 95% of the product will fall +2 and -2, and 99.7 will fall in the +3 and -3. So this 0.3% will be the rejection. This 0.3% will be the rejection. So this is the normal distribution curve. It is always bell shape because the product will always follow the center line. You can plot this graph with the help of histogram also. So dear learners, you can read this material from your book. I will take in the next lecture I will summarize this, and later on the process capability, will study the process capability based on this. Okay, thank you.